So we're going to go through 6.2, more practice with choice, and this is just the in-class quiz. Question 1 says, in the consumer's choice problem, what are the two unknowns that we solve for? It's x1 star and x2 star. Geometrically, what we're thinking about is, of course, this is the indifference curve, this is the budget line. We're looking for this bundle, and that bundle is x1 star, x2 star, and that's the most preferred bundle out of the consumer's budget set, one that gives them the highest utility. So question 2 says, what are the two equations we use to solve for the two unknowns? So the two equations are tangency and use all the income, so budget line. We don't want any money left over because that could be increasing our utility. The tangency condition is just that the marginal rate of substitution, the slope of the indifference curve, is equal to the price ratio, which is the slope of the budget line. It's these two things are tangent, and so their slopes are equal. So that's the marginal rate of substitution, and then the slope of the budget line is negative P1 over P2. And I can show you how to find, if you forget this on the exam, that the slope of the budget line is negative P1 over P2, there's an easy way to solve that for yourself. So that's the tangency condition, and the budget line is just that our expenditure, the price of good one times the amount of good one that we buy, plus the price of good two times the amount of good two that we buy, is equal to our income, which is M. Question 3 says, at the consumer's most preferred bundle in their budget set, why must the budget constraint hold with equality? We got to spend all of our money because more of good one and more of good two increase our utility. If we don't spend all of our money, that's money that could be increasing our utility. So we know that we're not at a utility maximizing bundle if we have money left over from our income, because any unspent income could buy more goods and increase the consumer's utility. It's not this one, because the consumer is assumed to allocate resources perfectly according to price ratios. That doesn't actually answer the question about why must the budget constraint hold with equality. Leaving income unspent would shift the budget line inward. It doesn't shift the budget line inward. That would just be modeled as we're buying a bundle that's within our budget set and not on the budget line. And then because equilibrium requires that income and prices remain constant while quantities adjust, that is just nonsense. It's not that one. Okay. Question 4 says, if the utility is like this with A and B as exponents, what is the log transformed version that represents the same preferences? So we just want to take the natural log of this, ln of x1 to the A, x2 to the B. First, we're going to use the product rule that says the natural log of a product is the same as the sum of the natural logs. So that's going to be equal to ln x1 to the A plus ln x2 to the B. And then the next rule that we'll use is the log exponent rule, which says that you can take exponents and bring them out to the front. The natural log turns multiplication into a sum, and it turns exponents into a product. So we can have, that'll simplify to A ln x1 plus B ln x2. That's the final answer. Question 5 says, why would we take the log of a Cobb-Douglas utility function when finding the MRS? We do this log transform for one reason, and it's so that our partial derivatives are easier to work with. Specifically, it's easier to take partial derivatives. Because when we take the partial derivative, when we want to find the MRS of this thing, it's much more pretty. That's just A divided by x1 divided by B over x2. Or simplifying, dividing by a fraction is the same as multiplying by the reciprocal. So A over x1 times x2 over B. So partial derivatives are just a lot nicer because the partial derivative with respect to x1 does not include x2 in it, unlike when we take the partial derivative of just this thing. So the answer is because taking logs makes partial derivatives easier to compute while preserving the same indifference curves and therefore the same MRS. And for question 6, consider this utility function with x1 to the 1/2, x2 to the 1/2, price of is 1, price of good 1 is 1, price of good 2 is 2, and M is 8. Take the natural log of the utility function to find that MRS, just like we discussed. So that's just take the natural log of this. We get 1/2 ln x1 plus 1/2 ln x2. Using this new utility function to find the marginal utilities, for x1 is 0.5 over x1, and for x2 it's 0.5 over x2. Right. Set up the condition, which is that the MRS is equal to negative P1 over P2. So what is the MRS? I'm looking at this, dividing by that. There'll also be a negative sign. 0.5 over x1. We want to divide by this thing, which is the same as multiplying by the reciprocal. So I'll just go ahead and multiply by the reciprocal. x2 over 0.5. This 0.5 in the denominator can cancel. Then I'm left with negative x2 over x1. We set that equal to the negative of the price ratio because that's the slope of the budget line. Question 6 tells me what the prices were. P1 is 1, P2 is 2, so it'll be negative 1/2. Negative 1 over 2. So this question asked us to do the MRS, so we were done when we got to here. The MRS is this, which equaled this. So that's right. That's what we found. In the next question, now we set the MRS equal to the negative of the price ratio. And then I think I just cancel a negative from both sides. So I get x2 over x1 is equal to 1/2. If we solve for x2, we multiply both sides by x1, then we get x2 is equal to 1/2 x1. So that's how I get this. And now to finish up the choice problem, we take this optimal ratio and we sub it into the budget constraint. Our prices were what? 2 and 4, 1 and 2. Prices were 1 and 2. So our budget constraint goes 1 x1 plus 2 x2 equals an income which was 8. We substitute in for x2 to eliminate x2. So we have an equation just with x1 in it. We get x1 plus 1/2 x1 equals 8. So we get x1 plus x1 equals 8, 2x1 equals 8, and x1 equals 4. And then finally, how much of good 2 does the consumer choose? We can put this x1 equals 4 back into our ratio. x2 equals 1/2 of 4, which is 2. And then finally, question 12 says, consider the utility function we use. x1 to the 1/2 and x2 to the 1/2. Amounts of goods 1 and 2 enter into the utility function equally or symmetrically. So why did the consumer not choose equal amounts of goods 1 and 2? We chose 4 units of good 1 and 2 units of good 2, probably because good 2 was more expensive. Our P2 was 2. So good 2 was more expensive, so we bought less of it than good 1. Price of good 2 was higher, so even though buying more of good 2 would increase utility, it would be more costly to do so. So the consumer balances the marginal benefit, that partial derivative of utility, with a marginal cost, which is the price. That's the answer there.